My name is Anton Louis Olivier. I'm the Managing Director of Bethlehem Hydro as well as New Planet. I'll give you a bit of background on the Bethlehem Hydro Power Plant. How did it come about that we developed and constructed the first privately owned hydropower plant in South Africa since the middle 1980s. In 1999 already, I was made aware of the opportunity for possible hydropower in the river system, which will be taking the outflow of the Lesotho Islands water scheme to Gauteng, specifically the area in the Eastern Free State near Bethlehem and Clarence. We went to site in that area, looked around and identified two specific sites which seemed to be viable for hydropower generation. One is at the wall of then still the Solspoor Dam, now the Solplaatjie Dam, and the other one on a stretch of farmland about halfway between Bethlehem and Clarence. We approached the government of the Netherlands for financing. Remember, this was in the late 90s. We approached them in about 2000 for grant financing to finance a feasibility study to look into the possibility of a privately owned small hydro power project in South Africa. Now, why did we think it was possible in those days? Remember, this is before the Eskom load shedding. We were still all sitting very comfortably, low cost of electricity. Nobody else was developing private power in the country at that time. My company started in the Netherlands together with a Dutch partner, and we were working internationally in the development and management, really doing project management on private power projects. So we knew that private power was happening internationally and was just a matter of time before it would hit South Africa as well. But the big question has always been for private power and any power project in South Africa is how to make it work financially, because our power tariffs have been and still are quite low. Because we were working internationally and specifically based from the Netherlands, we were very aware of the coming carbon credit process. In those days, it was before the ratification of the Kyoto Protocol, before the real implementation of the CDM, Clean Development Mechanism. But we were busy with a couple of projects in a precursor program of the Clean Development Mechanism. And we realized that because of South Africa's high emission baseline, Eskom's coal-fired power plants, it would be possible to generate a significant amount of carbon credits from clean renewable energy, and that would create an additional income stream which changed the financial viability of these projects. So it's with that basis that we went to the government of the Netherlands. They had at that stage a grant program to support such type of initiatives in developing countries. And it took a while, but finally in 2003 we were awarded a grant. We then proceeded with the development of the project, and it took quite a while. The biggest barrier in those days were the regulatory issues. Remember, nobody in the late 90s, early 2000s were approaching the regulator, energy regulator or water affairs with requests for power generation licenses. We were probably the first applicant for a hydropower water use application under the Water Act to Water Affairs. The banks didn't know what to do with a startup company, no balance sheet, wanting to develop a 100 million rand project on a non-recourse project finance basis. So there were considerable institutional barriers. The market then was completely different to what we're experiencing at present. But the long and the short of it is it took us quite a while to get the whole development process finalized, to get all the licenses, permits as required. The grant money available enabled us to contract consulting engineers. We contracted, in those days it was still Ninham Shand, it's now part of the Oricon Group, together with Mertz and McClellan as electrical engineers to conduct a technical feasibility study. The feasibility study concluded that technically hydropower is possible The hydrology was good. By that stage, the Lesotho Highlands water scheme was delivering an annual average of 25 cubic meters per second of water down the river system there. Our initial financial model showed that the project was financially viable as well, specifically based on the inclusion of the income from carbon credits. Bethlehem Hydro then also proceeded with the registering of itself as a carbon credit project, and I think it was one of the first 3 projects in South Africa which was given registered as a carbon credit project and approved as such by the South African government. It took quite a while also to secure all the necessary financing. Debt financing we sourced from the Development Bank of Southern Africa. In those days, none of the commercial banks would have looked at a small-scale project of this nature. The DBSA was willing to do that. And then we also had quite a process to secure all the equity investment it needed. But we managed to get that all together, and in December of 2006, our civil contractor mobilized to site. Our project design that we ended up with was very capital cost sensitive, because the power tariffs in those days were still close to around 20 cents a kilowatt hour wholesale prices, selling to the Dihlabeng, the Bethlehem Local Authority. Eskom in those days, if you ask Eskom if they want to buy power, you were lucky if you got more than 10 cents a kilowatt hour. So we got a good margin on that by selling to an end user. We went through an international procurement process on the turbines. We specified a water-to-wire package, which means it's the turbines, the generators, all balance of plant equipment, control equipment, all of that. We finally selected an Indian supplier, Boving Forest. They took over General Electric small hydro designs effectively. GE decided to get out of the small hydro business, and BFL bought their designs and was manufacturing it in India. They provided us with a very cost competitive package, and the efficiencies was also equivalent to what we were getting from the more well-known European brands. We went through a difficult tender process on the civil construction. It's an unusual project. It's a little bit small for its complexity. The contract value was also a little bit small for its complexity. And being financed by a development bank, we had to include a lot of development related tender criteria, which the contractors weren't too interested in. So effectively we had to relax some of our criteria and go for a second round of tendering. But finally the contract was awarded to Eigenbau, a Johannesburg-based company, civil and mechanical, which turned out to be very good, since there is a large mechanical component in a hydropower plant as well, all the sluice gates, the valves and so forth. The construction process, as I said, started end of December 2006, mobilizing to site, and effectively ran to our first commissioning was in November of 2009. So we had a 2-year construction process, which was, or actually 3 years, which was much longer than anticipated. And the reason for that is we had to make considerable design changes in the middle of the project. Geological conditions weren't what we were expecting. We did preliminary geological surveys. They gave data which were interpreted in a certain way, and afterwards it turned out that that interpretation was incorrect. So we had to make considerable design changes, which led to project delays and cost increases. But fortunately we were able to refinance the project, and that was mainly possible because by that stage power tariffs in South Africa was rising rapidly. So because of the higher income stream that the project would be generating, we were able to refinance, get additional debt, restructure the equity, and end up where we are now with 2 running power plants for Bethlehem Hydro. Bethlehem Hydro was a unique once-off project when we started it. We were in the consulting business, doing prepaid electrification in Latin America, wind farms in Latin America and the Caribbean, energy efficiency projects elsewhere in Africa, and we happened upon Bethlehem Hydro. But following on the successful construction commissioning of the project, I have reorientated our company, New Planet, into a dedicated hydropower developer, owner and operator. We are focusing preliminary on the South African market at the moment, and the reality is that South Africa is a semi-arid country. We don't have much of a water resource, and the bulk of our water resource is already captured in some form of transfer scheme, like the Lesotho Islands Water Project, which effectively is transferring flow from Lesotho, which would have run off into the Eastern Cape area largely, and a bit into the Orange system, and transferring it into Vaal River system. So South Africa has got limited hydropower potential. I guess probably we would be altogether, I know of about 150 megawatts worth of projects in South Africa, and maybe that's a half or a third of what's possible, but it's still peanuts compared to the wind and solar resource and the coal resource. So small hydro in South Africa, that's barring the building of big dams in the Eastern Cape, is unlikely to really feature significant numbers in the long term. But the projects that there are extremely viable. You can get quite good returns on these projects, and they can be financed. The only condition is the bulk of these projects are owned by government. They're on government-owned infrastructure, national government, water affairs, dams, water authorities, transfer schemes, local authorities, and nobody's yet successfully been able to secure private development rights out of any government entity. We've got a number of initiatives going, probably 6 or 7 initiatives going with different sectors of government, different strategies, to working with parastatals to address this issue. And it's a matter of time before the government will be comfortable with a way of dealing with this. So the potential in South Africa is good, but limited. And there's always the benefit of working in your own backyard, working in your own currency, borrowing money in your own currency and being paid back in your own currency. That makes the financing very easy. But the hydropower potential in the long run lies outside of our borders. If you look further north towards Zambia, Mozambique, Angola, Congo, there's incredible amounts of small hydro potential, and small, anything up to 50 megawatts range in those countries that's available for development. But the big issue in our neighboring countries are the weak electrical grid infrastructure. It's one thing having a great 10 or 50 megawatt or 5 megawatt project in a river somewhere. It can be a fairly low cost development, high availability, but you need to put 100 kilometers worth of power line up to connect to somebody who can pay for and is creditworthy enough to act as an off-taker to buy the power from you. So that is the big killer on hydropower projects outside of our borders at the moment, is the thinly spread electrical infrastructure. That being said, all our neighboring countries are at present upgrading their transmission distribution systems. Grid densities are improving. So we are very enthusiastic about the potential further on in the market for hydropower in Southern Africa. We've, amongst others, now secured the rights on a 5 megawatt project in the central south Zimbabwe, which we are developing at present. We hope to secure another project in Zimbabwe, and we're also looking at Zambia and Mozambique and Malawi as well for hydropower project. A lot of potential, but you need to be able to ship your power out and get somebody to buy it. And as the economies grow in our neighboring countries, the utilities are getting more creditworthy. The interconnectedness with the South African economy is improving, and the integration of the South African economy is improving. So our banks are comfortable to lend to projects in our neighboring countries, and that's what's required to make these projects financially viable. So the hydro sector is small in South Africa at the moment. There's more players coming to the market, but it's not going to be a huge project market, and probably if government starts making its projects accessible in 5 years from now, 90% of the potential of hydro will have been exploited, barring, as I said, big dams. And then those players in the South African market will need to look either diversify into other energy forms or look outside of our borders for more potential. We're very optimistic about the potential for private power in the South African market. The power sector moves in long cycles, typically 20-year cycles, and we're coming we're in the trough of one of those cycles now. For the bulk of the 80s and 90s, we had overcapacity, we had extremely low energy prices. Eskom was encouraging everybody to use more electricity. Quite the opposite from what is happening now. So we're now in a situation where there's going to be power shortages at least for the next 10 years, or tight supply and demand relationship rather, if we can avoid the load shedding. And our power prices need to go up. We've had historically low prices. Our tariffs probably need to double from what they were in 2008 within the next, by say 2012, 2013, to provide viable tariffs to make it worthwhile to put up new power plants, not just for the independent generators, but also for Eskom. Eskom is putting up Kusile and Medupi, two new large 4,800 megawatts, I think, or 4,200 megawatts coal-fired power plants. These are probably of the most expensive coal-fired power plants being built in the world. One of the reasons is the environmental regulations that are required by the international lenders, which are pushing the cost up quite considerably, and the consumers will need to pay for that. So we're seeing prices going up, and that's good news for private developers. In addition, the government has announced a renewable energy feed-in tariff scheme. This was announced in 2009, and we're hoping that it will be implemented, in that offtake agreements can be signed in the beginning of 2011, where we are now. And these tariffs make provision for specific renewable energy technologies. The government wants to diversify the generation pool that we've got in the country, away from just coal. It also wants to encourage private sector investment into the energy sector. And the best way to do it is with renewable energy technology, because these are typically smaller scale than large coal or nuclear projects, and thus more accessible to private players. Eskom recently, or the Department of Energy, went out on a call for expressions of interest for independent power, and I think they have received applications for 15,000 megawatts of renewable energy power projects. The bulk, 13,000 gigawatts of wind energy, and some photovoltaic and concentrating solar, and a bunch of others, amongst which small hydro. Now, these projects, all, if they qualify for the refit scheme, the subsidy scheme, they will require subsidized rates. Refit offers about R1.25 for wind energy, for example, above R3.50 for concentrating solar power, and the market price of electricity, the average at the moment, is about 30 cents per kilowatt hour. So we're sitting with a situation in the country where the government has made certain commitments to buy very expensive clean power, and that needs to be balanced in terms of the energy that will be produced, the emission reduction impact on our global carbon footprint, which will be minimal, and compared to Sasol and Eskom, whatever we can put up in terms of renewables is going to be negligible. And we also need to look at where our budgetary priorities are, because we probably still got about between 20 and 30% of our population not having access to electricity. And where should we be spending our money? Providing access to electricity or clean power to reduce our carbon? I believe we're doing the right thing and that we're focusing on both of these. And there will be big structural changes coming into the market because of the new players. Even though the capacity that they're going to be producing is going to be negligible in the first year or two, it's probably going to be a rounding error on Eskom's production figures. But the fact is there's going to be other generators in the market that's made considerable investments, which our financial sector has made investments in, and that will mean that Eskom's old position as monopoly supplier and the structure of the energy sector is going to be changed dramatically. Bethlehem Hydro, as I mentioned, was one of the first projects that used carbon credit financing as a part of its project finance structure. So we were one of the first players in the South African carbon credit market, and we've learned quite a bit about the ins and outs of carbon credit. The market has matured a lot over the last 10 years, but since when we were starting on it, but there's still quite some misconceptions about the realities of going for carbon credit financing and what does it mean. The typical selling point for carbon credits, and that what get everybody swayed into carbon credits, is a rising graph of carbon credit prices. You know, at the moment the market price is 10 euros a ton CO2. It's got to be 45 within 2-3 years. You know, everybody just sees making a lot of money out of it. The reality is that we've been in the market for 10 years and we haven't really seen significant shifts in pricing. What we have seen is that you can generate income equivalent to about 10 euros a ton of carbon credit on a project of this nature. If you've got a big balance sheet to back it up and you're willing to guarantee emission reductions, then you can get a higher price, maybe 13 or even more. But there's a lot of projects which get a bit lower. But the carbon credit process is not easy, and it's extremely rigorous. It takes a long time, it takes a lot of management time, it takes a lot of technical expertise to get the process done. It needs to be internationally audited. So the transaction cost is also quite high. An additional benefit to carbon credit that's very often used is it's good public relations. If you want to be shown to be or seen to be doing something about the global environment and your carbon footprint, carbon credits is a very concrete way of tackling that. And it's clearly measurable, and you generate some income out of it, which is quite good. But if you're looking at transaction costs, getting a carbon credit project started, local consultants will cost you probably in the order of 300 to 500,000 rand to get the international auditors in to audit and recommend your project design document, as it is called, for registration. That's probably going to cost you another 30,000 euros. And thereafter, annual verification, again by an internationally accredited specialist auditing firm, that's in the order of probably 15 to 20,000 euros again. So it's an expensive process, and you need to add on to that the own management time included. It's very similar to going for an ISO specification, the rigor that you need to apply in preparing for carbon crediting. So the volumes that you're looking at need to be high enough to justify it. And there's considerable risk in the process. We nowadays don't use carbon credits as a form of security for our debt financing. It just makes the debt financing process so complicated because the credits are denominated in a different currency. So the currency risk issue need to be incorporated, as well as normal carbon credit purchase contracts have some market-related features in there. So you've got some price fluctuation. So you multiply a couple of variables with each other, and that just leads to a lot of uncertainty. We still do carbon credits on all our crediting on all our projects, but we are not using it as a form of security. We just take whatever we can get out as an upside for it.
Hi, I'm Pierre Genidem. I am a qualified industrial engineer with a master's in engineering management. I have been working with New Planet from November 2009. I am the operations manager of the Solplaatjie and the Merino Power Station. The Bethlehem Hydro project has identified the Ash River as a suitable river for this project because of the constant flow that comes through the Lesotho Highlands water scheme. A constant flow of 27 cubic meters per second flows down the river, all the way from the Ash River and down into the Solplaatjie Dam. Bethlehem Hydro has two projects installed on this Ash River. One is called the Solplaatjie Power Station and the other is called a Merino Power Station. The Solplaki power station is rated at 3 megawatts and the Merino power station at 4 megawatts. For hydropower generation, you need three things. The first one is gravity, the second is mass, and then height. So we would utilize the flow of the river as the mass, the height, which we call the head, which is any drop over which the water falls, and then gravity, the constant 9.8. From that, we would calculate the potential energy, and that would give us the rating of our hydropower station. On the Bethlehem Hydro project, we use Kaplan full double regulated turbines, which means that the guide vanes and the runner blades can be controlled by hydraulic pressure. The water flows through the intake and into the turbine. The turbine then turns a shaft. The shaft turns at 250 RPM at this point and is stepped up to 750 by the gearbox. The generator then generates at 750 RPM at a voltage of 6.6 kV onto the transformer, which is stepped up to 11 kV. Through this whole process, auxiliary items control the oil temperature and the pressure required for generation. In essence, the turbine oil pressure unit controls how much water is led through the guide vanes onto the runner blades, which is a control of our speed. The second auxiliary item that we have is the gearbox oil lubrication system, which is a simple oil system which lubricates the gearbox and controls the pressure and the temperature at which the gearbox operates. The third auxiliary system of note is the generator lubrication oil system, which is also a very simple oil system which lubricates the two bearings on the drive end and the non-drive end of the generator. To generate power, we need to synchronize with the Eskom grid, and for that we need three things. We need a frequency of 50 Hz, a speed of 750 RPM, and a voltage on our generator bus bar of 6.6 kV. Now, this is all controlled by an automatic synchronizer as well as the PLC, which controls the speed at which the turbine OPU controls our turbine. For internal electricity usage, electricity from the Eskom overhead line is stepped down with a 100 kVA transformer for internal power station usage. Electricity moves from the generator to a step-up transformer from 6.6 kV to 11 kV. After the control system has synchronized our generator with the Eskom overhead line, the generator circuit breaker will close. We call this a switchgear. This switchgear type is a SF6 type gas switchgear, and it's of ABB make. The control system at the power station collects information from the machine room. This includes the auxiliary components, the turbine, the generator, step-up transformers, and consolidates them within the PLC. This PLC can convert all these signals into alarm signals if it is required. In the event of anything going wrong, an alarm will sound in the power station. The PLC will then send the required signals to shut the power station down. The first thing that happens is the generator circuit breaker is disconnected from the Eskom grid, and the emergency gate will immediately fall down to close the water off from the turbine. After any emergency conditions, an operator is required to put the power station back into service. Our plants are semi-autonomous in nature, which means that the plants can run and they govern themselves, but in emergency conditions we will need an operator to switch the plant back on. Low-head power station with Kaplan installations, the excavations are quite deep because you need what they call is you need a pressure difference behind the runner blades. So the turbine must be, in our case, 5 meters below the tail water race level. The tail race level is the level at which we put water back into the river. That avoids cavitation. Cavitation is the process at which a differential in pressure at the front and the back of the turbine blades causes the turbine blades to cavitate or erode. So the footprint of the power stations must be quite deep, the excavations. In addition to that, the type of configuration you choose will dictate the area at which the turbines are installed. We have a footprint area of about, I think it's 25 meters by 8 for the power station as a floor area, and it goes for about 5 stories high. As a first measure, we have a core screen which diverts any big logs or some animals that flows down the river. The forebay is the very first part of the intake. And then we have a fine screen which will collect small reeds and some smaller rocks or whatever that can flow through the turbine. So we have precautions for that as well. The turbine itself is rated to last for about 50 years. They're very robust, they're big pieces of metal. It's not very smart or complex equipment, but the control equipment, being telecommunications equipment, they don't last for too long. They have a lifetime of 5 years and some even less than that, so we replace components in there quite often. The bulk of the rest, like the transformers, they also last for maybe 30 years or 40 years, whereafter refurbishment is required on these equipment. Small items like oil filters and all that and consumables can last for months, so the difference between the turbine and the rest of the equipment is quite big. In some cases, parts are only made in India and we have to get them from India, and so the lead times on that sometimes involves loss of power or income for significant periods of time. But we're looking to replace some of the equipment, and replace it with new equipment where we can, and that is proving to be a challenge to manage that. We make our money by selling electricity bulk to ESCOM or the municipality. How that works is we have a substation at which we bill our electricity, and we have 2 electricity meters on that substation which measures the kilowatt hours per day or per year or per month, whatever the requirements may be, and according to that we will set up a bill to the municipality or the ESCOM. Currently we are on a time of use tariff, which is the same as normal domestic tariffs, apart from being a wholesale electricity tariff. There's peak time, off-peak time and standard time, and for different hours in the day they have different tariffs connected to them.